Hi, welcome back to video tutorial on AIOS. In this video, we'll be discussing an important aspect of AIOS, and the topic of this video discussion would be like cluster, node, block onboarding, policies of control. And this is a part 1 video. Part 2 video will have a little more complicated stuff. As usual, we'll be using Jupyter Notebook to explain or give a demo with the help of Jupyter Notebook. So this notebook provides an overview of certain features of AIOS, which is like cluster controller gateway, cluster controller, clusters, nodes, blocks feature of AIOS. And these features are designed to help the users to onboard, maybe to manage and to monitor their clusters, nodes, blocks effectively, and also to define policies of control. So what all those policies, what all controls user has in AIOS, that will be explained in this video. So the first component that we'll be discussing is cluster controller gateway. So the doc is provided here. So this is the doc, you can go through it, and similar content will be provided in the Jupyter Notebook as well. So what is basically AIOS is it's a network which has which can have several clusters. So anyone who has certain set of nodes, they can create their own cluster. So AIOS can have multiple clusters, and to interact with this cluster, to do anything inside the cluster, you require an interface, and that interface is provided by the cluster controller gateway. So this cluster controller gateway will be used by users, that is me and you, and a parser. Parser is again a separate component of AIOS, which I will not be explaining in this video, but we will be using it for certain of the task. So in this video, I'll be explaining mainly the functionalities of users, what all he can do with the help of gateway, that will be explained in here. So to execute multiple cluster level functionalities, we'll be using this gateway. And who is the owner of this cluster controller gateway? So it's basically the network owner. Let's say the AIOS is under some network owner, he will be creating the cluster controller gateway. So as this is the part of AIOS management service by default. So what are user level functionalities achievable in the cluster controller gateway are mentioned here. So you can query the cluster metrics, you can query the node metrics by providing cluster ID and node IDs. So you can update and delete the details of a cluster. Where is creation? So creation is a part of a parser. So basically, to create a cluster, we'll give a bigger JSON, and the JSON has to be passed by the parser, and that will take care of creating the cluster. So creation is not in directly in the hands of user, but user will take the help of parser. So update, delete details of a cluster, allocate, deallocate cluster infrastructure components by providing cluster clusters Kubernetes config file. So and also you can do node removal addition to the cluster. Let's say you have already one cluster, you can add a node to it if you have a new node being added into the cluster. And you can create a VDAC controllers infrastructure. Let's say VDAC controller, we have separate video for it, and whatever the infra required by the VDAC controller, to create those infra, we will be using this gateway interface. And you can execute multiple block level management commands. So whenever we hear this management commands, right, so it's basically user has written, like you and me have written certain policies, and these policies will execute some functionalities, and to update certain parameters of this policies, you will be using management commands. So blocks, whenever we create certain blocks, block is nothing but a model, or it's an intelligent or non-intelligent piece of code. Intelligent, it could be like the AI models or LLM models, or non-intelligent meaning a piece of a code. So whenever you want to execute some management commands on that block, so you will be using this gateway. And also you want to execute any management commands of a cluster controller, you would be using this gateway. And also to scale the blocks manually, let's say to upscale or to downscale. What is scaling here is basically to create multiple replicas of the block. So if you want to create multiple replicas, or you want to down certain replicas, you can use this gateway. You can use the gateway. So what all components are available in this gateway? So basically API server is available. So what is this API server? There are two API servers, internal API server and a external API server. So internal API server is mainly used by the parser and search server, which are the internal components of AIOS. So since they are internal components, they will be using the internal API server. And since user is an external entity of the AIOS, so he will be using an external API server. So all the user level functionalities that we are going to achieve will be used by the external API server. And a pre-check policy rule executor. So executor is one who executes a certain piece of code, and that piece of code we call it as policies. And these are known as pre-check policy rules. And that executor responsibility is to execute the policies that we are asking it to execute. So that takes the compute and that does the evaluation of those running of those policies. So since this gateway controller, gateway is under the network admin will write certain policies. Let's say a policy can be the policy, or a pre-check rule can be, like, say, whenever you want to onboard a node into the AIOS. So network admin could have put some rules to it. Let's say a minimum number of CPUs has to be this much. A minimum number of RAM has to be this much. If that is a rule of a network admin, then it has to adhere. So to evaluate those rules, you can write a add node policy rule. So similarly, to remove a node, so similarly to add a cluster, to remove a cluster, add a block, remove a block, updating cluster. So if you want to update the cluster details, network admin can put some rules to it. So those scaling a block, block management and cluster management, that's what the block level management and cluster level management APIs are. So whenever user wants to achieve any of these functionalities, network admin can impose some rules or pre-checks. So that's what pre-check rules is, policy is, and that will be executed by the executor itself. So that executor is a component in the gateway. And block allocator dry run modules. So this portion is not used by us directly, but internal components of certain other components like parser will be using it. So what this means is, let's say whenever you want to allocate a block before allocating into a node, it has to run a dry run, meaning like whether a RAM is sufficient or not. So those kind of things needs to be evaluated, right? So we'll run a dry run for it. So a block's resource allocation policy rule and cluster DB API clients are required for this particular dry run module, and needs a cluster controller client API. So what is a cluster controller will be explained later. So that APIs are required by this module to run this. So this has a block allocator and dry run module, so which will not be directly interfacing, but it will be used by the internal components. And cluster infra management modules. So let's say you are creating a cluster. Once a cluster is created, it requires its own pods or management services. So those modules can be created via gateway controller. So creating and removing cluster controllers infrastructure. And what all those, let's say a metrics DB. A cluster should have a DBs of their own. It's a metrics DB to collect the metrics of a cluster, metrics of a node, metrics of a block. So it requires a DB. So those services will be created, and creates a metrics reader and writer services, because you have a DB. To write something into it, you require some reader writer services. And metrics collector daemon set. So daemon set, which is of a Kubernetes asset type. So a daemon set will run in each and every node to collect the metrics of a node. Metrics here is, I mean, like, let's say what is the usage of a node, what is the RAM usage of a node, what is how much GPU utilization is there. So all such of metrics needs to be collected, and we have a daemon set for it. And creates a cluster controller itself. Cluster controller will have, again, we have a separate cluster controller, which I'll explain later. And configure the service ingress port mapping for the cluster controller, and updates the, to update the cluster entry. Let's say once a cluster is created, that entry has to be updated in the DB, global DB. We have we have local DBs which are local to the cluster, and also we have a global DB which is global to the network, which is under the control of network owner itself. So the cluster entry needs to be updated in the entry of the clusters detail, as well as the URLs of the cluster. Several URLs will be there, that needs to be updated in the DB. So that kind of jobs will be done by this cluster infra management module. So that is also part of a gateway. So next is a cluster node add remove module. So like whenever a cluster is created and you want to add or remove a node, right? So that will be taken care by this module. So basically add or remove node existing in cluster, node onboarding scripts will be run, and node onboarding scripts will be executed in the node to be added. Let's say basically the daemon sets that we are talking about, right? So that will be taken care by this particular module. And a VDAC controller, let's say whenever a VDAC controller needs to be created for certain by connecting certain blocks. So what all infras are required by the VDAC controller will be created in this gateway. And here it will not create the VDAC controllers unit, it will just proxy it, meaning whenever you need to use the gateway interface to create a VDAC controller simply channels it to the cluster controller to create the VDAC infra. And also it provides cluster DB, cluster metrics DB, cluster client modules for interacting with these modules will be used by certain other modules of the the gateway. So to understand further APIs explanation, so you need to understand certain JSON structures. So the sample JSON structures are provided here. So we'll explore the APIs available in this gateway, what all APIs are available in under individual components. So let's get started exploring the API. So let's say cluster read and write, right? So you have a cluster metrics reading. So for that we have some APIs: cluster read API, update cluster API, delete cluster APIs. And to get the metrics of a cluster, get the cluster metrics of get a metrics of a node, those kind of APIs are available. And scaling up and down the number of instances of a block, so that you can do manually. For doing manual, you have to use the gateway. And cluster infra creation. So we'll show you an example of how to create cluster infra by creating a cluster. First, what we need to do is you need to have your own cluster, Kubernetes cluster. It should have one master node for sure, because certain when cluster infra is created, that will sit in the master node. So you have to have one master node, and you may or may not have a worker nodes right now, but you can, if you don't have it, you can add it later. But in our case, we will show you both the ways. First, in the part 1 video, we'll be creating a cluster with some worker nodes in it. And so once our clusters are created, that cluster need to be registered in AIOS. How to register, we will show it using parser API. And once registration is done, registration here is just putting data into the DB. It will not create an infrastructure. So to create the infrastructure, we need to use the infra creation APIs. And to remove the cluster also, we need to use the infra creation APIs or infra deletion APIs of a gateway. And then VDAC controller will not be showing any demo here, because we have certain other videos for VDAC controllers, so that you can use it. But basically the sample APIs will look like this. So yeah, let's get started with the APIs that we have shown so far. How to use each and every APIs, we'll get started. So before starting a demo, I'd like you to check this important documentation. So where this documentation tells you various services are available and what their port is. So certain of the services we'll be using in our demo right now. Let's say it's a block DB services, cluster DB services. They are running in certain ports. So that's what the first block that we have to execute. So here I have taken gateway URL, which is running in 30,600. I'm using a demo cluster, cluster GCP2, and cluster global cluster metrics DB and global block metrics DBs. They are running in port 30,202 and 30,201. A parser URL, which will be using it for certain of a parsing activity, so which is running in 30,501. A global cluster DB. So this is a metrics DB, and this is the global cluster DB, and there is a global block DB services. So they are running in 30,101 and 30,100. And there is a task DB. Why this task DB is certain of our services are asynchronous in nature. Let's say parser URL. So whenever you give something to the parser URL, they will run task asynchronously. And once they accept the JSON file, they will send you a task ID to query the task what is going on with the task. So you have to use the task DB services. Component registry, so this is basically a registry service where to create any blocks, so you need to store the blocks metadata, like how the input structure is, how the output structure is, what is its parameter, what is its settings, all those details, and what is the container image that we need to use for that particular block. All those details has to be stored, archived in one component registry, that is a component registry. So that service is running in the 30,112. So I'm making it as a OS environment so that we can access by a curl command. So let me just run this cell. So it has created that in environment variable now. So now first is a cluster read API. So let me I'm taking the cluster gateway URL and a cluster ID, that demo cluster ID that I'm using. So let me just run it. So it gives you a big JSON to you. So a lot of information, like these are our metadata related informations, config. So these are the, like you have URL mappings, right? So those are internal components of the cluster. So those URLs are available here, and what all total number of GPUs in the cluster, what is total memory in the cluster, what is the cluster ID, network interfaces, nodes. So in this node, how many nodes are there, what all individual nodes data. So you have all those details here. Again, node data will be like GPUs, memory, network, storage, swap, vCPUs. So these are basically collected by the daemon set that we have run, and they will push this data. So this is just about the metadata of the nodes, not about the current usage. That is what we call it as a metrics. So this is about reading of the cluster details. Next API is about updating. So I'll not be using, because I don't want to update anything right now. So you can use the clusters update command. So you can give any update, any tags you want to update, any other details you just have to provide a JSON. I'll not be using it. Delete cluster I'll not be running right now. Maybe later on I can show that. So get metrics of a cluster. So we shall collect with the help of gateway URL. So we'll collect the cluster metrics. Now you just have to provide the cluster URL. So here is a whole cluster metrics. So this is aggregated metrics of a cluster, and this is the individual nodes metrics. So here you have a GPUs. This is a CPU only node, so there is no GPU, is empty. It has a network interfaces related metadata metrics, a storage metrics, and vCPU metrics. And this is a GPU node, I guess. So that's why it is showing you a GPU utilizations and also GPU and GPUs. So this is together summed up version of this particular GPUs. So here it is about individual GPUs metadata it's providing. So this is in one node, and that's memory. So similar to you will get for all the nodes metrics you will get. So this is about the metrics. So now we queried it from the gateway URL only. So there is other way you can query it also, using a global metrics DB, global cluster metrics DB URL. So URL is created above itself. So you just have to provide the cluster ID. So this will also provide similar data like what we get from the gateway URL. So now if you want to collect individual metrics nodes metrics, so you have to use get this API, like from the gateway URL. You just have to provide the cluster ID and the node ID. So whatever the data you saw for the whole cluster, right, in that one node's data will be available here, the similar structure without any structure modification. And right now okay, so this is about a cluster reading the metrics cluster metadata. Now we'll talk about upscaling, downscaling manually. So what is upscale or downscale is basically you have created a block, and for that block number of replicas you want to increase it. So how to do that? So here is the details. So first we'll check to get the blocks detail, like one block has been already registered and it's running already. So I just want to check this particular block. This is a block register small 2506 llama CPP block, and I want to get the details of this block. So you can just go to global block DB service, and you just have to run this command, which will fetch a lot of data related to the block. So what all block data will be there, like whenever block is initialized, what data it went with, and whenever you are registering, right, so you have a block URI and which cluster it is running in, that cluster details will be available here, and also a component. So component is what I was talking about, component registry, where when you are creating a block, you need to provide the component, you need to have a component being registered. So what are those component details, what is the initialization data, component parameters, protocol schema, component init setting protocol schema, all those things are available here. So once so this way you can query the block details. So next API is about a blocks metric. So let us from the global metrics DB service, I will collect the blocks metrics. So let us run it. So it is showing instances array and a block ID. So in the instances you have two things right now. There is one executor. Executor is not a actual block. It is a a compute which will run the policies of the block. So it will not have any other metrics like how many inference it has done. All those details will not be available. And here is a actual instance. So this instance is what all its CPU usage and all it is given here. What is the GPU, what is the state of the GPU right now when this model is running. All those details are available here. And so again, certain metrics like these metrics are implemented internally inside the block. So those metrics it is listing here, like what is the total tokens per second, all those details like inference duration seconds, GPU utilization. So all those details are here. And like there is an on data function and on preprocess function. So there are two functions in each and every block, on data and on preprocess. So their FPSs and latency are also noted here. Right now no inference would have been done, so data are initialized to 0 only. So here there is an node ID in which machine it is running in, and there is an instance ID. This is INMKAU is the instance ID of it. So let me try running let me do a manual scaling of this. So then let us see how this data will change. So I'm going to scale this block. Operation is scale, not a down scale, and there is a block ID and instance counts. I want to run two instances. One is GP node 2. In GP node 2, I'm going to use, there is a two GPUs are there, and in both the GPUs I'm trying to schedule, and there is a GP node 1 in that I'm going to schedule in GPU 0. So let me run the manual scaling now. So yes, I got a success. So let me just check the how this global metrics behave. So it will take some time for a global metrics to get this data. Yes, now the second instance it's trying to create, and third instance also it is trying to create, and it's trying to collect. It doesn't have any this kind of metrics. It will try to get it now. Let me run it again. Set to get. Let me run it again. Yes, it is collecting some informations. So here is the instance ID. So and one other instance. There is one other instance. So let me run it again. One more instance it has to create. Yeah. So the total two instances. So two more instances are created, and you can check whether they are created in the node that we wanted. In GP node 1 and in GP node 2 it is created. So this is how to scale the blocks manually. So let me downscale the blocks manually. So you need to provide the block ID, operation is downscale, and you need to provide the instance ID. So let me just copy the instance IDs. This is one instance ID. These instance IDs are system generated, so I don't have any control over how the string look like. Let me just copy this second instance. So there were only two instances. So let me try to delete it. So right now, if I delete it, it will not reflect immediately in the metrics. So it will take some time. But yeah, this instance are deleted. We got a success message. Let's say if you're trying to delete instance which is not available, if you try to delete it, right? So it will definitely throw some exceptions. So this as I told, updation of this metrics will take some time, every half an hour they will get updated. So I'll not be able to show the updated content if I visit after half an hour or 20 minutes back later. I'll get this details available, the cleared out. So this is about the downscaling operation. So in the next demo we'll show you the cluster creation, cluster controller creation. Now let us see the second portion of this video, which is cluster controller. What is cluster controller? So to know more about cluster controller, there is a doc. You can take care of this doc by going to this link. So basically, cluster controller is a suite of services deployed by default on each cluster. So whenever a cluster is added to the AIOS, it'll put some services, and those services are required by cluster controller. So those services are known as a cluster controller. So it is responsible for orchestrating and managing life cycle of a block running within the cluster, not just the blocks, about the VDAC controller as well. So it handles onboarding and deboarding of nodes, monitors the health of nodes, pods, and ensures high availability through the automated failure recovery mechanism. So what is the procedure to create the cluster controller? So you need to go through these steps first. First of all, you need to have a cluster. So let's say you have a cluster with a master node and some worker nodes. So if you have a master node and cluster node, first you need to create a Kubernetes cluster from your side. So how to create that? I have a detailed steps here. So yeah, first you need to on a master node, you need to go to the master node and you have to run this following scripts. So sudo bash master node install master node.sh. So those files are here actually. So you can cluster setup. So there is a master node. So those are the files, and for the worker node, I have a separate files. So you can run this command. Basically, what it does is it require whatever the prerequisites are there, right? So those will be installed, run times and whatever the apt installs required, and kubectl's K8s binaries. So then at the end, this will print a join command. So that join command you need to collect it. So that join command would look like something like this. And to run the Kubernetes kubectl command, so you need to do this three operations, where you will take the admin config folder so that you can execute a kubectl commands. And once the Kubernetes cluster is created, you need to run the via networking interface, which is pvnet here. So once the master node is up, now you have to go to worker node. So if worker node is having a GPU, you need to install the NVIDIA driver by downloading the latest NVIDIA driver from their website. And once the driver is installed, you can run this sudo bash GPU node install worker node and join command. And you need to provide the join command that you have copied from the top. So this is the complete join command, you need to copy it. So this script basically installs the prerequisites like whatever the apt-get installs and kubectl binaries, K8s binaries, and at the end it will join the cluster as well. So again, you can copy the you can create this kube folder, and you have to copy the kube config from the master node to cluster, worker node, so that you can run the kubectl commands. And once the container everything is installed, right, you should do this, you should not forget this NVIDIA container toolkit. You need to deploy it in your worker node. So first follow this instructions, like some 2-3 instructions will be there at the top itself, so you can run those commands to get the container runtime toolkit. So once the worker is ready, you can always check kubectl get nodes to check whether the worker nodes are ready or not. And you need to run this particular annotation gpnode.sh. So you should not use sudo here. And why you need to do it? Basically to understand whether this is a GP node or not. So you are annotating the that particular node. So you have to run it in individual worker node only. It's not on a master node. It tries to check whether it has a GPU, and if GPUs are available, it will try to extract the name of those GPUs, and it will try to annotate the node. Then you need to replace the toml files in master node as well as in worker node. So I have shared the toml files in this directory itself, so you can copy those toml files and put it in containerd config.toml. And for worker node also I have separately provided. So once you replace it, you just don't forget to do container D restart. And this, if you have n number of worker nodes, you need to do it in n number of worker nodes. So this creates a cluster now. So now once cluster is ready, how to onboard that into AIOS. So now you need to register the cluster into a AIOS. So how to do that? Again, we'll use the help of a parser API, and I will show in the later section how to do it by how to register a cluster into the AIOS. And upon registration is just about putting it into some DB. So AIOS have global cluster DBs, right? So it will dump the details into the DB, and after dumping into the DB, you need to run the cluster controller infrastructure. So how to do that? We have again APIs for it, which I'll explain in later section. So before going into a practical showcase, so I'll just show what is cluster controller from the doc. So these are core responsibilities of a cluster controller. It's provisioning and decommissioning of a block infrastructure, and acting as a proxy for executing administrative and management commands on the block. So blocks will have several policies. So in those policies, if you want to run the management commands, right, so it acts as a proxy here. Basically, this will pass on the instruction it has received from the gateway controller and a controller gateway, and then it will pass on to the blocks here. So allocating compute storage resources for newly spawned instances due to auto scaling events. So this also the cluster controller does this, and also it coordinates with the cluster controller gateway during initial resource provisioning phase for the blocks, and deploying and tearing down a VDAC controller infra, scaling VDAC controller components as needed, onboarding and de-onboarding the cluster nodes, and continuous health monitoring of cluster node spots, automatic reassignment of workloads in case of any failure happens in the node, or in case of any failure happens for the block, meaning like pod. So it also has a lot of policies that we have enforced. So this is the architecture of a cluster controller. So here you have a API interface for the cluster controller, and first is like say block data. So block data CRUD API. So you the block whenever you deploy a block, it will be basically sitting in a global DB, block DB. So to do the CRUD operations, right, so you require an interface. So this unit will provide the interface, and this interface will be used by all of the components here, where whomsoever needs the block related information, right? Let's say there is a stability checker or infra manager or dynamic infra, whomsoever needs it, so they will use this interface. So next is a block event processor, which is basically here. So what this does is basically responsible for receiving any events from the block. So block here is a, like as I explained in the previous video also, like it's basically a piece of code. It could be an intelligent or non-intelligent. Intelligent meaning models, non-intelligent meaning any piece of code. So if they have to run in AIOS, it has to use the AIOS instance SDK of ours. So in this AIOS SDK, there is a particular class file that needs to be used to create any events. Let's say you have some coding failure, let's say exception occurs, and you want to notify some user. Some user could be one who has created the block. So how to send that information to the user? So that kind of events you can trigger from the block itself. It could be for failures, it could be for notifying any other informations of the block. So any other informations you can pass on to the events processor, and this event processor will receive the events from the block, and you need to register what for this event, what is the policy needs to be run for this event, what is the policy needs to be run, that needs to be registered when block is getting created, and based on that, block events will process those policies by taking once it receives the events from the block. And then we have a dry run and resource allocator. So basically, whenever block is getting created or block is getting auto scaled, why auto scaling is required, let's say it has getting more and more hits. So if you have told like, hey, blocks can go from minimum instance of 1 to maximum instance of 5, if more and more hits are coming and it is not able to take the hits, then it has to auto scale. So during auto scale events or initial phase, you need to do some activities like where it needs to be deployed. If directly you have provided the GPU node and GPU ID, then doesn't matter, it will directly take that and deploy it. But auto scaling event, you will not be able to provide those details directly, so you have to have some policies. So those policies will help us in identifying where to deploy, which node to use, which GPUs to use. Then infrastructure management module, which is basically this infra manager, as you can see that it is in direct talk to Kubernetes. So this is responsible for creating the blocks or VDAC controllers, any pod related matters, right? So this guy will take care. And let's say next is a dynamic controller scanner, so dynamic infra scanner, so which is nothing but dynamic infra here. So this guy is responsible for several things. So let's say whenever a new node is added, and this guy will get that information from the Kubernetes that new node has been added, and it will pass on this information to rest all the blocks. And also, let's say when a new node is added, we need to deploy a daemon set. So this guy will be basically responsible for deploying those daemon sets. Why daemon sets are required? Again, for getting the metrics and hardware details. And also, it not just that, it also checks the health of the pod, the block. Pod is nothing but right now it's a block or VDAC controllers pod. So any pods is having some issues, so this will identify that. If the one node is down, this will identify that, and this can talk to the infra manager. Let's say if pod is down, so it can talk to infra manager to create a reassign a pod maybe to somewhere else. So that kind of task the dynamic infra will do it. Source controller, right now, so the source controller is basically tasked with scheduling, managing GStreamer based video ingestion streams for inference workload. So here is a source controller. Let's say you have a video, or you have a RTSP stream. If you want to process that, so the source controller will take the stream, and it will pass on to certain other pods, and that pods are responsible for breaking those videos or streams into frames, and then pass on to the blocks that is required. Then there is a management command center, which is basically the parameter updater. So here this parameter updater is like whichever policies we write, right, as a user. Let's say it could be a stability checker, or it could be dry run or scoring policies, or any blocks will have any number of policies. So for all those policies, we will have management APIs, management functions. So those to trigger those management functions, we will use this parameter updater. So basically, I will be talking from the gateway controller to parameter update, gateway to cluster controller. In the cluster controller, the parameter updater will receive any updates required, and that it will channel. Basically, it will does the proxying. So if that belongs to a stability checker, it will pass on to the stability checker. If the command is for a block, then it will pass on that information to the blocks executor for the updating the policies management commands. And then is a stability checker. So this is responsible for cluster stability policy. So you will be writing certain policies here to check the stability. So basically, it will get all the information that is needed. Let's say what all nodes are available, what all blocks are available, what is the current metrics. So based on that, you need to come up with an say yes or no, like whether the cluster is stable or not. So that kind of stability checking this unit will be doing it. So like how we had pre-check policies in gateway, right? So like in the gateway, we had add node, remove node, add cluster, remove cluster, where these policies are written by the network owner. Similar to that, we have pre-check policies in the cluster controller. But here it will be written by the cluster owner, not the network owner. Let's say in gateway, the network admin says like I need minimum of 2 vCPUs to be onboarded in this network. In the cluster, he can put more stricter rules. No, I need only 8 vCPUs. If 8 vCPUs are there, then only it is valid for getting added in my cluster. So that kind of rules cluster admin can have. And for that reason, we have provided policies for a cluster admin to be added, to remove node, add node, update cluster, scaling the block, adding a block, removing a block, adding a VDAC controller, removing a VDAC controller, and block management and cluster management. So these are the certain policies that is being exposed in the cluster controller. So these pre-check policies, they have to return this kind of a data, allowed, true or not, and input data, whether it's modified or the same input data, so you can pass on. And if it is not allowed, you have to return a false, and any message you want to give it, or any dictionary you want to send it, you can send it. So the typical structure of policies will be like this. So has a eval function. It has to return allowed true or false based on the evaluation. So we'll show you some examples in the part 2 of this video, how to write a policy, let's say a policy for a add node. For add VDAC controller, so the input data will be like this. It has VDAC data, cluster matrix, node ID, input data, all those metadata are available. So you need to check, you need to evaluate whether VDAC controller should be added or not. Like let's say cluster matrix giving the all the nodes in the cluster is full, there is no space, let's say, or let's say like it's 80% occupied, the vCPUs are 80% occupied, then you are not interested in running the VDAC controller here. So you can strictly say no, I will not allow. So you can send the allowed equal to false. So that kind of policies you can write. Remove VDAC controller. Again, it's for the removing of a VDAC controller. So we'll explore certain APIs from the documentation. So infra management APIs. So here block create action APIs. So you want to execute some command on the certain blocks. So there is an execute action command. So in this execute action, you have like a remove block, create block, parameter update, scale, dry run, remove instance, init create status update, query init container data, reassign instance. So this kind of actions we have for a execute action. So we'll use one action in the end of the demo. It could be like reassign instance action. We'll try to show. And these actions, who will be basically using it by? Like it is used by the cluster controller, gateways, management command executors. So all those details are provided here. And for VDAC controller action API, let's say you want to create a VDAC controller, so you just have to post this. This we have shown in the some certain other videos, like VDAC videos, how to create the controller, how to use the VDAC controller, how to create the controller, how to down the controller. All those details we have shown in other videos. So here, like create controller, remove controller, scale controller, list controller. So again, these actions are used by cluster controller gateways mainly. So basically, whenever you talk to cluster controller gateway, that will be passed on to the cluster controller. So cluster action APIs, like say you want to add a node or you want to remove a node. So those are these APIs. And next, let's say get cluster details. So to get a whole cluster details, right, you can use this API. Update cluster. So if you want to update certain details of the cluster, you can use basically this endpoint. So next, blocks query API. So you want to query the block, like what all blocks are available, what is the detail of this particular block. In such cases, you can use this. So this you have to provide the block ID to get the details of the block ID. This will return the information of all the blocks currently running in the cluster, not in the whole network. It is just about the cluster, because this endpoint is about the cluster only. So you can write MongoDB kind of queries as well. Let's say query cluster reputation is this much, policy autoscaler, something like that. MongoDB kind of query also you can do. And also you can do certain metadata updates for the blocks as well, using block update and give the block ID. Let's say when you created a block, you found that okay, 1 to 2 instance of a block is okay, but later on you identify, if you want, no, I just want to create more instances because more requests are coming. So then you can basically do a update. Next, dynamic infra scanner related APIs. So healthy nodes, so it will return healthy nodes based on certain policies. What is healthy is what we need to define it, so that we have separate policies. And node status, so whether the nodes are healthy or unhealthy, it will return all the node status to you. So stability checker, check stability. You are basically manually triggering it. So there is already stability checker going on as a on a time, let's say 30-second one. So but you can manually trigger that as well. And this management command I'll explain here. So management commands. So this management commands, you have to provide like 4 inputs. One is block ID service. So if block ID is empty, then it is for stability checker, because stability checker policy is for a cluster, right? So you don't require a block ID. If block ID is empty, then the service has to be a stability checker for sure. And what is the action you want to do, and what is the data you want to do. Let's say some parameters of stability checker policy that you have created, you want to update it, then you can update those parameters by giving what is the action you want to do and what is the data of that. So if it is not a stability checker, you want to update certain blocks want to activate certain blocks management command, then you have to provide the block ID here. And then services are either instance, executor, autoscaler, health. So if you provide a service equal to instance, then what happens is you have your block code which will do actual inferences, right? So for them you can update the dynamic parameters. This will basically does parameter update for all the instances, all the pod instances of the block. So if it is an executor of a block, so block has an executor which is basically does the policy implementation, policy running, all the policies that you write, right? So this executor will run those policies. So to do some management commands for that, you can send that executor here. And for autoscaler also, you have a management command you want to send, you can do it here, as well as for health endpoints. So block event processor, like as I explained, let's say you want to send some notification to the user when some condition is met, or send an event when some internal failure happens. So for triggering those kind of events from the block, then you need to use the block event processor. So block event processor basically will be sending this data to you. You have to write a policy, right? So it will send an event name and it will send a event data. So these two things our block has to send that. And AIOS instance, since you are using AIOS instance to your in your block code, so it will add the block ID. So you don't have to explicitly add it. So you have a policy of the structure eval. So basically you will receive this input, and based on this input you need to act. So let's say your this policy right now, I'm going to send a mail. So you have to write a mail sending code by taking the event data from here or event name from here. So when you are registering a block, you need to give what all events are okay to receive for this block. So I'm just giving on some key event name and what is the policy name I want to activate. So basically event blocks event processor, as soon as it receives this event name, it will activate this it will execute this particular policy. This policy is basically stored as a zip file. It will download the zip file and it will execute that. Let's say if there is a one more on caught exception or something, it will execute on one more policy. So you need to write this policy, basically one who creates the block code, right? So if they want some events to be handled, so if they want to write some events, so then they have to write the policy and upload the policy. So how to integrate into AIOS instance code? So AIOS instance has this blocks event class. So this will be passed to each and every whenever you have a main.py, right? So it will be passed on to that main.py and init this events. So that events you can take it and you can do a push event function, and in that push event function you need to supply the event name and the event metadata. You don't have to supply the block ID. That will be taken care by AIOS instance. And stability checker, again you will be given with cluster data and node data. So in the cluster data it will have details related to the whole of the cluster, and node data it will be like details related to each of the nodes. Based on that you need to bring in come to a conclusion whether this cluster is stable or not. So let's say if all utilization of CPUs are 80% full, then you can say like cluster is not stable. If disk is somewhere around 90%, so you can say no, cluster is not stable. So that kind of events you can pass on. So at the end what it requires is stable, true or false is required, and any stability check data you want to pass on. Next is resource allocator policy. This will show you an example, like whenever you create a block, right? So it has something known as resource allocation policy. So in that policy there are 4 functions we need to implement: dry run, allocation, scale, reassignment. So we'll show you what we can do for allocation and reassignment. Any complicated policy also we can write it, but for demo sake we'll show you a simple policies. So writing resource allocation policy, you will get an action and you will get a payload. And in the action, whether it's a dry run, allocation, resource reassignment, those kind of actions will be there. In the payload, it depends on the action. So for dry run you have block, cluster, cluster matrix, health node, whereas for allocation you have block, cluster, cluster matrix, health node, and similarly it will vary for a scale also. Like scale you will get a healthy node. The return type of a dry run action is always it has to send this kind of key selection score data, and it has to send a score and it has to send a node info. Whereas rest all other functions, it will return node ID and GPUs, where this has to be scaled or deployed. So a simple code is given here. Let's say if the input data action is a allocation, scale, or assignment, it has to pass on node ID and GPUs. And if it is in dry run, it has to send the selection score data. So this is about the cluster controllers and its APIs. So we understood how to create, how to first of all create a Kubernetes cluster. We have some scripts, and then we gone through the cluster, what all components are there in the the cluster controller. So that we have seen. Now we will see the demo of it. So let's create a cluster controller now. So in the previous example, I have shown how to create the cluster setup. So I have done that for my small node. I have created a small node of one single master node is available, and two worker nodes are available. So this is the two worker nodes. So this cluster is created, Kubernetes cluster is created, but it is not yet added to the cluster. So let us go one by one step. So first, to create the cluster controller, we need to register this in the AIOS using parser API. So here I am using parser API. API create cluster is the endpoint, and I am providing the cluster onboarding to AIOS cluster1.json. So let us look into the cluster1.json. So cluster onboarding cluster1.json. So here it has a header and a body. In the body you have what is the ID. So I'm giving a name of a GCP demo cluster and your central one region and status live, and some informations. Right now I'm not going to provide any details about the nodes. Let the daemon get those details. So I'm keeping the nodes data, GPU details, everything to be empty. CPUs, storage, network, everything I'm providing empty. And I can provide some tags to it. I can configure also, like what is the executor name, public host name. So right now I want to I know that the master, it's a public IP of the master node, and it is a local IP of the master node. So and that I need to provide it here. And in the tags you can provide any tags that you want, like GPU demo, AIOS, and anything like production, all those things you can provide. Next is a cluster metadata. So you can give any name to a description, one or email. So there is no control here we have provided. So you can provide anything, you countries, US. So basically you can use this later on to write any policies to say whether let's say if node has some information like country, so if that has to be in this node cluster or not. So those kind of checks you can do later on. So cluster metadata can be given, any other information related to cluster you can give. So this is basically a JSON. So if I run that, what happens is now cluster will be put into the DB. So let me do that right now. Yes, this cluster data is put into the DB. So let me query it using global cluster DB, and I am giving the cluster name. So it has brought all the details about the cluster that is being added. So right now, till now, this data is not yet updated. The reason being is cluster infra is not yet ready. So as soon as we register the cluster, once we cluster registration is over, next is we need to create the cluster infra. So let us create the cluster infra first. So to create the like if you want to update any cluster related information, you can use this API. And now to create the cluster infra, here, you require the Kubernetes clusters, the config file. So that I'm already copied, like I'll not be providing in the GitHub. Maybe you have to copy it, like your home, this file you need to copy, like cube.config file will be there, right? So that file you need to copy it, and you need to put it in this path wherever you are going to run, right? So in that path you need to provide. So that will have all the credentials required, things like that, IP and all those things will be available here. And this is the API URL, which is nothing but the gateway and a create cluster infra. So is the endpoint that we have to hit. So this, if I run this, I have already copied this config file here. So once I run it, let us see what happens. Before that, I'll just run some commands related to the controllers. So there is no namespace like controller or anything here, no pods are available. So once I run this, we'll see what happens. So task is scheduled, so we can check always the task, but since I have the access to the controller, I can do this kubectl get pods n controllers kubectl get pods matrix. So let me do the controllers. It's not yet ready. Yes, so now it's the control. Basically, right now AIOS is dumping a lot of service in this particular cluster. So there is a demo cluster controller. This is the cluster controller we are talking about. gRPC proxies, membership servers, so certain services it is running. Yeah, right now it is running. So let me check one more metrics related things. There is a metrics namespace, in that also certain things will be created. So running, yeah, all things are running. So now we can check the infra again. So let me run this command again now. Now you can see that a lot of things getting filled by the cluster controller, because it has run certain of its services in certain places. So now it has updated this. It has updated the GPU counts related metadata, network, CPU related, what all nodes are there. There are three nodes. One is without, it's a master node CPU node only. One is a GPU node. It has one is having L4 machine, sorry, L4 GPU, and there are two T4 GPUs with 15th GB 15 GB RAM. So, and also memory, what is the memory of individual machine. So all those things are filled by the daemon set that runs on each node. So now that we have created the cluster infra, now let us like, yeah, this is the Python program. So if you want to do it the curl, so you can do this. Only thing is you need to provide this whole key value pair. So instead of me providing key value pairs, I just run the Python script here. So once the to removal again, you can use this. Right now I will not do that. Later stages I will do that. So you have again the curl command. Again you need to provide the kube config, but right now Python file is also available here. So you just have instead of create cluster infra, right? So it is a remove cluster infra. Nothing changes. So you can always use the task ID. This is the global task service, and you can give the task ID. It will show whether status is pending, if you have completed or not. So once, let's say now cluster infra is removed, so you need to remove the cluster entry also if the cluster is not needed anymore. So for that you have a delete global cluster DB, and you need to delete that. So this will do it at the later stages. Now let's say cluster is created now. So let us start and block. So before that I'll show you this JSON. So first I need to register the component of a block that I want to run. So this is the registration command. So you need to say component, you need to hit it to the component registry service, not to the gateway URL. So API register component you need to do. Once that is done, so you can do a unregistration as well. I have provided here, and then you can do a deploy block. So this also having a different JSON. So first we'll go into that JSONs demo block. So component demo. So it has several key value pairs. So component ID, it is having name, version, release tag. So this will be clubbed together to form a URI later on. So that we call it as component URI. And container registry info. So where this things is hosted, like where the container is hosted. And then component metadata. So if you want to give any sort of your metadata information, right, so that you can provide here. I'll not go in detail for this. And component init data. So whenever component is initialized, meaning like a block is initialized in the init function, you will send the init data. So right now I'm sending model name and system message as a init data for it. And this is wherever you see a protocol, it means a schema related. So there are four parameters. Since it's an init parameter, there are four parameters. One is temperature, max token, top p, min p. So temperature is it's a number, sampling temperature, min 0, max 1. Some, like, it's a schema basically. You have to provide whether it's an array, object, a number, or a string. All those details you need to provide it. So this is the input parameter, and input settings also we have. So in the settings we have some some more things. So that also has similar structure like type object. So if it is an object, you can, if you have data related to some keys of it, so you can say it as a properties. So in this, it's a model config is an object. In that properties, in that nctx, ngpu layers, n threads, seed, verbose, these kind of properties are available. And next is the input protocol. So input data will be received in eval function. So what will be the structure of it? So it can have message key, it can have prompt key, it can have text key. So message is mainly for maybe a chat purpose. So if you are doing a chat kind of operation, you require a message, and a prompt, input prompt for generating a token. So if you want to generate a token, you require a prompt kind of a key. If you are generating an embedding, you want to generate an embedding from the model, so then you require a text key as an input. Session id, system message, default system message, what should be system message for chat initialization. Gen params, again this is an object, so I not provide the details of it. So next is the output protocol, what it should output. So it can give a replay key, it can give a generated key, it can give a tokens key, it can give an embedded key. Like if it is a message, chat message, it is a replay, then it's generated, and it's a token generation, it's an embedding generation, it is simply text generation, not a chat. So again, component parameters, what initialization parameters, basically like this is the schema I have defined, and for this schema the default values can be this temperature 0.2 token 2048, these are the default values. And this is when component registration happens. Okay, so this is initialization settings. And what all management commands are available in this component. So all the reset, info, seed, some management commands are there that I'll not go in detail. And a tags, you can provide any tags to here. So now this first we need to register this with our component registry. So that's what we'll do. I guess I have already registered, but I'll try component demo registration. Yes, the component URI already exists, so I'll not again, let's not do a registration again. So we can always try like registration also, that also works. So now once the registration is over, we need to deploy the blocks. So for deploying the block, I require the allocation demo mistral.json. So here mode is allocate, allocation, I'm forcing for allocation, and this is the block ID I want to give, and component URI is what the model dot demo magistral llama. So this is what the component is, demo magistral llama cpp10 stable. That's what the component URI is, and minimum instance is 1 and maximum instance is 3. This is for basically autoscalar. And then block init data. So though I have given some block init data here, block init data as a default value, I can always modify that. So during the registration I would have given something, but block initialization I would have done some changes. So here is a model name and a system message I have given, and then init settings. So in the settings also there might be some default values by the component registration, which is here, initialization settings, that I can modify in the init settings. So similarly, init settings, we have init parameters. I would have, right at the end, the block will take this values only to start. So if you're not provided, it will take from the component config. Component config is a fallback. And policy rule spec. So as I told, like whenever you are creating a block, you have to define some policies. So what are those policies is mentioned here. One is a cluster allocator. So this policy will be used to select the clusters available. So right now, let us see how the cluster allocation policy is. Right now, yeah, I'm writing a straight, hey, just run it in this demo. I'm not making a complicated structure. So we have some other videos for this, like you can write a query like you can write, hey, I need the best this cluster, that cluster. You can write a different queries for it. Right now here, I'm hard coding. The ID should be equal to GCP demo cluster. So this is the cluster allocator policy. So next policy we have is resource allocator. So in which node it has to be allocated. So for that, right now I'm directly supplying the node and GPUs. So this policy I will show basically what is this policy, resource allocator policy, and how this allocation data is taken and processed. So this is the resource allocator policy, and there is a load balancer policy. Again, yeah, this is important. So here we are using policy URI, right? So we need to register our policies, and I have already registered this policy. So again, for every policy you need to provide the policy URI for sure. So you have to write the code, you have to upload the code into one place, and then you need to register those policies. And if any block takes those policies, now the blocks can pull those zip file and process those policies. So this is resource allocator. We have a load balancer. Load balancer is basically, like, say you have multiple instances, how to pass the the inference request. Right now, by default, this load balancer 2.0 stable is a round robin. So if there are 5 instances, it will go via round robin fashion. So you can write your own. Let's say you can check whether this node is whichever node is a bit low compute. I mean low metrics is bit low, like it's not being heavily utilized. You can channel that. So you can write your own policies for it. So similarly, you have a stability checker. So this is for the stability checker of a block, not of the cluster. Cluster, it is a separate. This is the block. So then next you have is a autoscaler. So autoscaler is how to autoscale. So you require some inputs for it, like what's how many inputs it is receiving. So what is the latency, all those with the details. You can take a call on whether I need to autoscale or not. So that kind of policies you need to write it. So right now I have maybe dummy policy is being created. So this is the allocation data. So this policy URL URI spec is very important in this. So so before that, I'll just explain the resource allocation policy code I have. So let me just go to resource allocation policy. Yeah, just before that, to register component, you have like the register component.bash is available, which if you run this it will take this component and it will register it into the registry. Then all those things are already available in this the Jupyter notebook. So now let me go to a policy. So I have a allocator here. So in this allocator, let me just open the function.py. So as you can see, there are actions. There are third-party allocation, dry run, allocation, scale, and a reassignment. So I'll just explain this allocation here. Right now, allocation data, if you send, right, so this is the key that we had in the allocation. So allocation data, node ID, GPUs. So if you provide this date allocation data as a key, so then my function will process that and it will return that as a GPU node it has to allocate. If not, some by default it is using some default node. So this node is not available in this cluster, but yeah, so it's simply returning. So my expectation is I'll be always sending this allocation data. So next is a reassignment policy. So I'll show you how to reassign, meaning like a instance ID is running already. I just want to move it from one node to other node. So for that, reassignment policy can be used. Here I need to send an there will be a payload along with the action. You will get a payload. In that payload there is an extra data key. So in that extra data key I can send a allocation data. So this allocation data is also having a similar structure of this or whatever, like similar to this, and that itself I'm returning from this function. So this is my simple very simple policies. So for auto scaling and other policies, right, we have separate videos for it. Let's say load balancer, auto scaler, scaling, so all those we have a separate video for it. So right now let us run this deploy the block first. So for that, right now if you see this this file, allocation file, I am trying to run it in my cluster and I'm using the demo worker node 2. Let me run the demo worker node 2 here, demo worker node 2. Let me run NVIDIA SMI just to show the blocks deployment. So let me deploy the block now. Yes, it got a task. So let me just go and check. Instead of putting a task ID and checking, let me just check the NVIDIA SMI. So now this is going through all the services of infra cluster controller. So and at the end it will try to deploy the model. So model is getting deployed now. Yes, since I gave 2 GPUs, so it is deploying some of the layers in first GPU and some of the layers second GPU. So now the deployment is over for the block. So let me, to get the details, like you can use the same, we have seen this in previously, how to get the details of the block, you can get that. And to do an inference, right? So you need to run this you need to run an inference server, because if you want to, since you are doing an ad hoc inference right now, you require something known as inference server, ad hoc inference server. So how to deploy that in this cluster, I have given details here. So you have a inference server.yaml. So that you need to, let me just show you that inference server.yaml. Inference server.yaml. So you need to provide certain details like, hey, this is the demo inference server. I'm giving a name, and what is important is this one, this IP. You should not. This is the cluster IP, whereas this is a networks IP related, like search server and block DB URL. So you don't have to. This will come from the network admins. So this is the server's URL, and this is what very important. So you don't forget to change this, because I'm creating a new name, right? So this is the demo inference server as a name, so you just have to keep that same here. And yeah, sorry, this is the service name. So this is the service name here, demo inference server. So certain other ports are there. So it's a very simple, straightforward. It has a deployment and it has a service. So that you need to deploy it. So how to deploy? kubectl create namespace inference server. So first create the namespace, then deploy the inference server. So I have done already, so I will not do again. So once the inference server is available, you can do a inference a curl request. So I'm trying to, this is the inference server's endpoint v1 infer, and I'm saying this is the model, and just create some dummy session IDs. Let me create some sequence IDs. So let me try to do an inference. So I'm just asking for give me an adding to integer list element wise in Python. So it's an LLM model. So we'll see what it returns. Since it's the first inference, right? So it might take some time. Yes, we have received the inference response. So I will not be going in detail with the response. So this is the deployment. So now let's do a reassignment. So before reassignment, I require what instance ID I want to reassign. So right now this demo worker, so now this block is deployed in GP node 2, like that's what I was showing here, GP node 2. I will shift it into GP node 1. So let me run the NVIDIA SMI -LMS. So actually this node has a lesser RAM required by the model, so it will not run, but I'll just show that the reassignment policy works. So before reassigning, you require for reassignment you require an instance ID and the model name, sorry, the block ID. So let me get the instance ID. Sorry. Yeah, so this is the basically blocks metrics I'm getting. So in that I can see the instance ID of the model. Yeah, this is the instance ID. So let me copy it and put it here. And now I'm asking it to assign in GPU node 1 and GPU as GPU ID 0 and demo worker 1. It will reassign it, but it will not run. The reason being is it has a lesser RAM. So, and it's a known fact for me. So let me try to reassign. So the action is performed. So let me go into the details. Yes, the model is trying to create, yes, and this has to get deallocated. We shall see that. Here it should not increase. Now maybe it's in the error state. So, but we need to see whether this is getting deallocated or not. Yes, it got deallocated. It will not run for sure because of the RAM issue that I have already seen it. So let me again, try to change it back to the GPU node 2 only. 0 and 1. There are two T4 GPUs, enough RAM for it. So let me run it. So the instance ID is same only, it will not change the instance ID because it is just the reassignment. Yes, so action is performed. Let us see now what happens. Okay, it started allocating here. Yes, it's taking the RAM and it's allocating here. So this will go vanish now. So first it allocates the model, then it will try to terminate the model. Yes, so the model is created here. So this way you can reassign. We have activated the reassignment policy of the resource allocator. So to remove the block, so you can run this command. You need to give the block ID and you have to use the gateway URL. So let me run it. So right now it is running in GP node 2. Let me run it. Yes, action has been performed, and let us see the model getting evicted. Yes, model is evicted. So now what we shall do is let's remove the cluster infra one by one. So we have created a cluster to the inference, and let us get back to. So first we'll try to remove the cluster infra. So for that we again get back to this. So there are metrics. So let me remove the cluster infra now. How to remove the cluster infra? It is already given here. This is a bash command. This is a Python command. I'll be using Python code. Yes, cluster is removed. So in some time, it has to go. This services, suite of services. Yes, it's terminating. So this will go. So those services are terminated now. So once the cluster infra is removed, so you can remove the cluster entry from the DB as well. So let me run this command. Let it terminate. Yes, it is terminated. All the services of the cluster controller is removed. And now let me delete the entry from the global cluster DB. So let me run this command. Yes, it is removed now. And if you query it, it will not be available. So let me try querying it from the previous example. Demo cluster, GCP demo cluster. Yes, cluster not found. So we have created the block, we have removed the block, we have removed the cluster infra, then we have removed the cluster entry as well. So that's it about this video. So we have seen basically what is cluster controller, what is cluster controller gateway, what is cluster controller, then how to create a cluster, how to onboard the cluster into the AIOS, and then how to create the block inside the cluster, how to do the inference using inference server, and then how to remove the block, how to reassign the block, how to reach certain policies of the block, and then we remove the block, then we remove the cluster infra, and again we have removed the cluster from the DB as well. So we shall see some complex things from the next video. Thank you.